In this video, we will be discussing section 9.4, which begins on page 575 of your textbook, and the title of the section is Solve Polynomial Equations in Factored Form. So before we have solved linear equations, and we have also used the foiling process and distributive property in order to multiply out polynomials. And we've also used that with special, patterns and polynomials in the last section. In this section, we are going to be undoing that process, and that will be called factoring. So our first key concept is the zero product property. Let A and B be real numbers. If A times B equals 0, then either A must equal 0 or B equals 0. So if I plug, let's look at scenario 1. If A equals 0, 0 times B equals 0, which means 0 equals 0, so that's a true statement. Or the other scenario is if B is 0. So I don't know what A is at the moment. A times 0 equals 0, 0 equals 0, that's also true. Alright, so when I'm multiplying and the product, so the result here equals 0, one of the pieces of the product has to be 0. So we're going to be using that to solve for x. So in our first example here, instead of it just being one number, I actually have a binomial, x minus 4. So x minus 4 times x plus 2 equals 0. So I rewrite the original equation, and then I establish my zero product property by saying either x minus 4 must equal 0 or x plus 2 must equal 0. And then I solve by adding 4. And I solve this one by subtracting 2 from each side. Alright, and I get x equals 4 and x equals negative 2. Respectively. So the solutions are 4 and negative 2. How I would write it is x equals 4, comma, negative 2. Do not put parentheses around it. It is not a point. You can write it like that, or you can write x equals 4 or negative 2, or you could write it like this. Alright? So how you check the solution is to substitute into the original equation. So just like I did on the very first slide, you would substitute in those values for x. So 4 minus 4 times 4 plus 2, I get 0 times 6, which does equal 0. And then I do the exact same thing for negative 2, and that would confirm that both of those solutions would produce a 0 equals 0. So those are my two solutions for x, for sure. Alright, the next concept here is factoring. So to solve a polynomial equation, use the zero product property. You may need to factor a polynomial or write it as a product of other polynomials. So when I'm looking at factoring here, or finding the GCF, what happens is what I need to look out for, my C, when it's written like ax squared plus bx plus c, alright, my C, or constant term, equals 0. Alright, so that's just something to look out for. So you are not going to see a constant term. You are going to see, a couple of other terms here, and you're going to have to find the greatest common factor in order to actually go through the full solving process. So let's look at an example. Find the greatest common monomial factor here. So they just want us to find the factor first. So the greatest common monomial factor, I need to look at both my coefficients and my variables. So let's look at our coefficients first. I've got 12 and 42. So I need to be thinking about what is the greatest common factor of 12 and 42. So if you're not 100% sure on how to do this, you can visit page 910. One way to do it is you can break 12 down into its factors, so it's prime factorization. So I've got 2 times 6, which is 2 times 3. So 12 is 2 times 2 times 3. And 42, if I were to do that for 42, it'd be 2 and 21, and 3 and 7. So this is 2 times 3 times 7. So the greatest common factor, they both have a 2, and they both have a 3. Alright, so the greatest common factor equals 6. So yet again, a little bit of review is on page 910 to find the greatest common factor. So what that means is I can take that greatest common factor of 6, which goes into 12 and 42. That's the biggest number that I can divide both of them by evenly. And so then I undistribute it. Alright, so I factor it out. So when I divide both of them by 6, I should get 2x plus 7y. So that is like undistributing. Alright, so factor out the greatest common monomial factor. Here you might be able to recognize that right away that 4 is going to be a greatest common factor. And then I also need to look at these variables here and their exponents. So how many can I take out of both of them? So the first term here has 4 x's and the second term has 3 x's. So I can take 3 out of both of them. Alright, so the greatest common factor between 4 and 24 is 4. Greatest common factor is going to be x cubed between x to the 4th and x cubed. So the greatest common factor, the greatest common monomial is 4x cubed. So I undistribute a 4x cubed, which means I'm dividing each term, and then I'm putting that 4x cubed out front, which that would result in x plus 6. Alright, so guided practice, so go ahead, pause the video, try these out, and then some solutions will appear for you in a second. Alright, so looking at another example here, we are going to be using that idea of the greatest common monomial and greatest common factor to solve. So solve an equation by factoring. What I need to do is always write your original equation, and then I need to identify my greatest common factor. So if I look at my coefficients here, that's going to be 2. I can divide both of them evenly by 2. I'm looking for the highest number to divide by. And then both of these terms have 1x that I can take out. So undistributing a 2x, I would get 2x times x plus 4. And if you distribute that, by the way, that's one way to check. You would get 2x squared plus 8x when you distribute and multiply. Alright, so that should check out. And then, using the zero product property, I set each piece of this product equal to 0. And then I'm going to solve. Alright, so when I divide on both sides by 2 for the left piece here, and I subtract 4, I get x equals 0, or x equals negative 4. So the solutions are 0 or negative 4, and keeping in mind how I like to write it is 0, comma, negative 4. It's just a little abbreviated way. That comma there stands for or and. Alright, so solving 6n squared equals 15n. This time, we do need to put it into standard form. So one note that we should take is get all terms on one side. Alright, which means put it into standard form. So here we are looking for kind of an ax squared plus bx plus c. Alright, putting it in decreasing polynomial order, and we always want it to equal 0. If it does not equal 0, we can't use the zero product property. So our first move should always be to move everything to one side. So we do that by subtracting 15n for both sides, and then we identify our greatest common monomial, which is going to be 3 in the case of 6 and 15, and then n with n squared and n, so we're factoring out a 3n. We're undistributing that, and we result in a 2n minus 5. Set each piece equal to 0, and solve each piece. And yes, it might be a two-step equation here where you have to add 5 and then divide by 2. And you might result in a fraction, and that's okay. Alright, so our solutions are x equals 0 and 5 halves, or 2.5. So, looking at some guided practice, why don't you guys go ahead and pause the video, and then check your solutions. Alright, so using vertical motion here, this is just a common formula, and this is used all of the time in physics to model the height. So no matter what speed it is a projectile, an object is thrown into the air. Typically we talk about balls, rocks, or bowling balls. This is the equation that models that. Alright, so when I plug in the time, which is modeled in seconds, and the v velocity or speed, and then s, which is the initial height, we are going to get an output of the height that it is at. So we're going to be using that equation here in the next example. An armadillo. A startled armadillo jumps straight into the air with an initial vertical velocity of 14 feet per second. After how many seconds does it land on the ground? So write a model for the armadillo's height. So that means I'm using that equation. H equals negative 16t squared plus v times t plus s. Alright, and using the information from our problem, I'm going to be substituting in a 14 for the v for velocity here. And my initial height, s, is 0 because it's starting on the ground. So that's a little bit of a hidden piece of information within the words. So then I simplify it by getting rid of that 0 term, and then I need to use that negative 16t squared plus 14t and identify my greatest common monomial here, my greatest common factor. And I also substitute in 0 for the height, the output here, because I want to know when it's returning to the ground. So I need to solve for t. So the greatest common factor between negative 16 and 14, so we're really just looking at the 16 and the 14, is 2. And then between t squared and t, so I'm factoring out a 2t. I'm undistributing a 2t. I set each of those pieces of the product equal to 0. And then I solve. Alright, so I get t equals 0. So at 0 seconds, or t equals 0.875. So at almost 1 second. So the armadillo lands on the ground after 0.875 seconds after the armadillo jumps. So the reason why we eliminate the t equals 0 is because at time 0, the armadillo hasn't jumped. So it can't, jump off the ground and return to the ground in 0 seconds. That doesn't make sense. So you just might get, that's called an extraneous, well, that wouldn't be an extraneous solution. It's just a solution that doesn't check out, all right? It doesn't make sense in the terms of a real-life problem. So why don't you try guide to practice number 6. So in example 5, suppose the initial vertical velocity was 12 feet per second instead. After how many seconds would the armadillo land? So pause and see if you get the same answer. Alright, so the armadillo should land on the ground after 3/4 of a second after the armadillo jumps. So it makes sense that instead of it being 14 feet, if it was 12 feet, so it was a lower height that the armadillo is jumping, that it would return a little bit quicker instead of that 0.8, just about. Alright, so if you guys have any questions, please feel free to ask via email or Google Classroom. And if you need some additional review on greatest common factor, please don't forget that is on page 910.